Okay, so everyone, I think we're gonna just start in sharp. So thanks for participating in the technical workshop today. And our guest today, we have actually a quite big team today. So as showing on the screen right now, here's the topic. So I guess I just gonna hand over to Cloud, who gonna start the presentation.
Right, thank you, Zhangping. I hope you guys can hear me. Just write in the chat if something's not okay with the quality.
I can hear you quite good.
Yeah, all right, cool. So yeah, welcome everybody. First, I want to rectify the topic of our presentation. I think it might have been a bit misleading, judging by the tweets we've seen that advertised the presentation. This presentation is not about NEO governance mechanism. So it's not about the integrated governance mechanism in NEO N3. This presentation is about a DApp, which has a governance mechanism included in it. But this is not the NEO N3 governance mechanism. So we're going to show you a smart contract implemented in Java and want to give you just a bit of inspiration on how to do this. So with that being said, we can introduce the team. So we're Axe Labs. We're a small team from Switzerland based in the city of Zurich. We are a community, we're a part of the community in NEO since about 3 years now, 2018. And we're passionate about open source software. So blockchain space is ideal for us, we think. And we really want to contribute to the developer experience. So we want to improve the developer experience in the blockchain space and in NEO specifically. So we are Guilherme on the left side. He's also going to be part of this presentation. Then me in the middle and Michael on the right side. He wrote the smart contracts that are the basis of this presentation here. So we're going to quickly give you a motivation on why governance is important. We're going to talk about governance concepts and then show you the use case that we have built around governance about this topic. And in the end, you have the chance to ask questions. And so starting with the motivation basically are online communities. And what I mean with online communities are communities that form around a common goal or a common vision, but they're scattered over the whole world. So in a community that is local, you know people directly, right? You can meet them in person and you can build trust like this. But in an online community, you can't build trust like this. So you need a different mechanism to efficiently coordinate an online community. And blockchain promises a solution for this. And that is in the form of the decentralized autonomous organizations, also called DAOs. Well, you've probably heard of DAOs already. There's like a lot of them. One example is the MakerDAO, which hosts the DAI, the stablecoin on Ethereum. And DAOs promise us to remove a central authority, right? They're autonomous. There's no central authority. And they allow us to, it's often about the money in these communities. So they allow us to pool funds and the money that these communities have and have mechanisms in which they can allocate those funds in ways that every participant can agree on. And the word governance is already quite important here. DAOs need a governance mechanism to bring all these participants together and give everybody a voice in the say about how funds are going to be allocated or how a project should advance. And that's where governance is an important part about. And now Gil is going to give you some information on governance concepts. I'm going to hand over the sharing at this point.
Yes, just a second. I'm going to share here my screen. You guys can see it? Claude?
Yeah, it's fine.
Oh, that's good. Okay, let me do slideshow here. Current slide. Yes, exactly as Claude was explaining. So the whole motivation of this organizations or these communities, there's a driver for this. There's how can I say, a solid base which is the governance that drives these communities. And then I would like to go more into the governance concept. What is governance in the blockchain? So we just wrote it here that a kind of definition over an overview or a high level definition, which is enable stakeholders to discuss and make decisions on how the blockchain or a community or a dApp should evolve over time. And I know that is quite generic, but there are some drivers and to make this happen. And a predefined consensus mechanism to execute the proposals is pretty important. Exactly like Claude mentioned in the first, when he was starting this presentation, what we're exploring here in terms of governance, this concept is applied in the new in3 today. But our presentation is not about the new governance, but how this governance concept on how the stakeholders can discuss and make decisions in the blockchain are built. So imagine that you have a DeFi protocol. You want to build a DeFi protocol in UN3, or you want to build some kind of a dApp which enable people to vote on certain proposals, etc. So that's what it's one abstraction level up than the core governance of the new N3. So this predefined consensus mechanism is important to enable these decisions and to execute proposals, etc. This governance, this mechanism, these things can be on-chain or off-chain. Should have on-chain governance and off-chain governance. So in the area of on-chain governance, some examples are users can create proposals to add or remove or change parameters or values in smart contracts, and they have to follow a certain protocol, some methods in smart contracts, and also to after these proposals are created, you need to execute them. But what about the off-chain governance? So once the users create these proposals there or propose changes, they need to discuss. They need to get together. These communities need to get together and say, like, oh, let me explain a bit better what this proposal is all about. There are, of course, forums where these on-chain proposals are presented and discussed. It can happen also in GitHub, of course. But the important thing is that discussions can happen off-chain, but the decisions and verifiable claims should be necessarily on-chain. And as I said, like in the previous slide, this mechanism, this consensus mechanism should be implemented somehow, and the smart contracts are the foundation to build a governance protocol. Okay, so going a bit more into our use case and in the practical terms, what we'll present here today. So how a dApp with simple governance mechanisms can be built on UN3. So this we're gonna create we created actually a dApp. We're gonna share with you in the next slides. Also the GitHub repos. We just made them public like recently. But with this dApp, which is an example, you guys will get more familiar with the technology stack, and we're going to show code to you. And we aim to motivate users to build on N3. So not only dApps with a governance mechanism, but I mean, in general, using the technology stack that we're going to show you today. Cool. Okay, so let's go. So today, one of the dApp that they're showing, we have this technology stack. Yeah, let's start with the smart contracts. We're going to be using Java and Gradle, and of course Neo3j. So we from X Labs, we are the maintainers of Neo3j. Yeah, we're gonna show you some nice. Claude will show some nice concepts on the smart contract side, and also how like all these functions that enable governance, how they look like. So to interface with the smart contracts, we have a web-based application written in Next.js in React, and this web application is also public. We just made it public recently, and the very important part here is that it's a very nice application integrated to Newline, which is the external wallet, the browser, like the browser wallet of New. So this is the tech stack. As you can see here, we don't have a backend. We could have a backend here in between the smart contract and in the web-based application to do some caching or to have some convenience layers or a small like database to help the users to display other information, etc. But we decided to simplify and just have smart contracts on chain, web-based application interacting with the smart contracts and also interacting with the wallet. Okay, so let me introduce a bit like Neo3j. I think most of you guys are familiar. Neo3j is a project which is composed of an SDK to interact with the new nodes in the new legacy in the new N3. It has a compiler, Neo3j compiler, that you can write Java smart contracts and compile to the new VM. We basically have this Java Kotlin JVM community, these get-togethers, and I mean, if you are a JVM enthusiast, we would like to hear from you. So drop us a line, tell us what you're building. We can support you in some way. So the last thing is the Neo3j was first released in 2018, and we had like some traction over time. Here is we have on average between 3,000 downloads per month, 4,000. It depends on our releases as well, right? So just to give a very brief introduction, here in Neo3j, it's basically you can write smart contracts as you were writing Java code. So here is on the right is just a hello world. You have a static method which is called the bongo cat. You can also put some how can I say, annotations to tell what your smart contract is about, what are the authors, the name, and Claude, we're going to explain a bit further the capabilities of these annotations in Neo3j while developing smart contracts. And so just giving a bit introduction of Newline as well, which is also part of the tech stack of the dApp. Newline, we cannot avoid on comparing Newline to other projects in the ecosystem in blockchain, right? And one of what very well known these days is MetaMask from the Ethereum blockchain. And as you can see, here is my browser, and Newline stays as an extension. It's a Chrome extension which you can install, and is the same way as MetaMask. You can interact with dApps in the browser in Chrome. So here's an example. So here's your browser. You can click here in the Newline icon. You can create a wallet, for example. Select the chain, in this case Neo3. Put a name and enter your wallet password to be created, and then you have here back up your keywords. This is just a test. I just going to skip this. But then in the end, you have your address, your assets, your balance, the transactions that you've done. And it's pretty convenient to play and to interact with dApps. But this is like from the user perspective. What about like the development for developers, how to integrate? So I will not go so much in detail in the front end part. But it's pretty simple to integrate Newline. We have they have some beta documentation already, and basically what you have to do is to instantiate a Newline in3 object, initialize it, and then based on this object, you can do you can interact with the new blockchain, get balances, or invoke send transactions to the chain based on a specific wallet. Every time that you do some invocation, a pop-up will appear, and then you can authorize this transaction or not. So of course, in order to be able to use this Newline in3 object, you have to listen to specific events. For example, here I'm listening to the ready event that as soon as Newline triggers this event, I know my application knows that I can instantiate this object and interact with the chain. Okay, cool. So we've seen until now the tech stack of the dApp, of the use case that you want to show. And now I'm going to introduce you the real use case that we'll be discussing here. So is the meme governance dApp. I think the best way, the best thing is that I show you what is the meme governance dApp. But just to mention that we didn't publish yet in Twitter, but we're going to do later today. Here are the two repositories for the contracts and the front end of everything that we're going to discuss today here. So let me just stop here and let me go to to my browser, and here you have the meme governance new URL. And in this example, we just made how can I say a landing page, a very simple landing page, which this dApp is all about memes. So the best memes ever, built and governed on in3. So what you can do here in this dApp is that it basically is a kind of a protocol where you can propose proposals to add new memes. And also you can propose to remove the memes on this protocol. And of course, once you go to the dApp, I'll show you in a while. You can see what are the memes which are currently elected in the protocol. So yeah, this is basically a boilerplate of a landing page written in XJS. You can fork it. You can just modify if you want. I think this is pretty useful if you want to do something similar in a hackathon. So okay, here's the landing page. What about the dApp? So if you click here on your button on the right, you go to the dApp, and in here it's looking for a wallet. So here it is, the dApp. Basically, the dApp, the implementation looked for my Newline, which is here on top, already installed. If it were not installed, it will show here Newline is missing. Can you please install it? Go to this URL. Since I already have installed here, it's all fine. So here I can see the memes which are already elected. So yeah, there are some cool ones. I particularly like these ones, new in3 devs and if devs. Let's go here. These are the proposals. So how it works is that you can create a new proposal, and by creating a proposal, it will be listed here with this meme ID. The proposal type is either to create a new meme or to remove a new meme from the protocol. And here is in progress. So if this proposal, when I create this proposal, the proposal is valid for voting for, I think, 10 blocks, right, Claude? I think it's 10 blocks. And exactly. So, I mean, during 10 blocks, the users can come here and then press to vote up, or like to vote against it, in favor or against. During this period of the proposal is in progress, you cannot execute it. So users, the protocol will not cannot execute either the removal or the creation, whether it passed or not through a democratic process. Let's put it this way. So let's try it out here. I'm going to create a meme. So let me say here that is the best developer, best dev experience in the blockchain industry. I'll say just best DevX. So here in the description, I will say like, developers have everything they need to develop great apps. And here in the meme URL, you could go to, for example, meme generator or anything and create. I already pre-created one here for us. So this is the meme that I generated. It's a JPG. So new N3 developer experience is the best in the industry. Changed my mind. So this is the image, which is the meme. You're gonna like place it here. I will calculate already the image hash already. You're gonna fulfill here, and then I'll press create. Once I press create, the new line will be here invoked and ask to unlock my wallet. So I just put it like the password, log in. It will ask to pair with my wallet. In this case is Alice. I'll just press connect. And once I press connect, it will come this other screen here saying, oh, this is the transaction. The scope of this transaction is global. The risk is high. Please, are you sure that you're doing this? So it's because this is a test example, is an example, of course, and we put it like the scope as global, but we could adjust this. So here it will tell the gas, and here in Newline also you have all the signers and the things on the details of the transaction. You're gonna press like yes. Once you press, the transaction is submitted. And then you have like to wait a bit until the proposal comes here on chain. So here we go. It's already the block is already there. So here's in progress. So I'll just press here and vote. I'll vote in favor of this proposal. So here we go. I'm with LS wallet. I'll just say, okay, I accept. I'll submit the transaction. Transaction submitted. So here you go, and then the votes will appear here. I'll just go and go with other wallets. So with Bob, for example, I will vote together with Bob. I already see that there are 2 votes here in favor, which is nice. Then I'll just vote once more. Someone already voted in the meanwhile. That's awesome. I'll just vote yes. Submitted. That's great. So let's see. Okay, 3 votes in favor. So I cannot, as a user that create this proposal, is of my interest to execute this proposal, but actually I can't execute this proposal. Why? Because it's still in progress. So in the smart contract, and you're going to see like later on, if it's in progress, the proposal cannot be executed. So yeah. So we have to wait there a bit more. So look, votes in favor, 6 votes already. That's amazing. That's the top voted meme ever. So it's awesome. Thanks, guys. Yeah. Then let's wait a bit more. But in the meanwhile, what I have to explain to you is that for accepted memes, which are here, I can remove it. I can also click here. Anyone can click here and propose to remove these meme. Yeah, which is as we wrote in the landing page, we can dump the worst memes because yeah, it's sometimes people propose not so funny ones. Yeah. Cool. Yeah, the votes are piling in. Yeah, guys, thank you. Just let's wait here some blocks because then the proposal should the voting period should end. But yeah, so this actually is the DApp, is /DApp in the repository in the GitHub. you guys can explore there and see the skeleton of the dApp, how we built it. Any questions, just come to us afterwards. Okay, so here now it's in progress is no. It means that anyone can come here and click on this button to execute a proposal. I'll do it. I'll spend some gas. I have like many in the testnet. So here we go, is 0.6 gas, and I will say yes. Okay, transaction submitted. It means that the proposal is there. So as you see, it's already updated. So the proposal is not here anymore. And then the proposal is already accepted, which is awesome. So guys, yeah, so this is the very basic governance like mechanism that you can build with smart contracts and interacting with that. So since I already show you like the meme governance, I'll go back to the slides. Now I think it's time to hand over to Claude, that he's gonna show a bit more on data objects and the structure of this app.
Yeah. Okay, let me share my screen. One second.
Yes, I can see it.
Okay. So yeah, you have seen how the app works. Now we're going to go a bit more into the smart contracts that are underlying to this app. The data that's being stored in the smart contract is pretty easy, pretty simple. There's a meme and there's a proposal class. And the meme is made up of the ID, the description, the URL, and the image hash. And we already had this question in the chat. We don't save the image data on NeoFS at the moment. We just take a URL that points to the actual image, and then the front end has to resolve that URL and show it to the user. So they were planning to also integrate NeoFS there. That would be nicer to have the fully integrated experience. And then on the other side, we have the proposal, which also includes a meme, of course. It has to have the whole information of a meme. And you have a flag if it's a creation proposal or if it's a removal proposal. Then you have the block in which the voting period ends, and you have votes that are in favor and votes that are against the proposal. That's all the data that we store in our dApp. And our smart contract architecture is divided into two contracts. So on one side, we have the meme contract, which is the authority on whatever is stored as memes, as the memes that have been accepted are stored in the meme contract. And you can see the meme contract has below in the stores section down there. It has a pointer to its owner, which is the governance contract on the right side, and it has the memes. Yeah, like I said, it stores the memes. That's all it stores. It doesn't have another owner. The only owner that it has is the governance contract. And the governance contract, on the other hand, is the main entry point to everything in the meme contract. So you can see the front end does not interact with the meme contract. It only reads information from the meme contract. It cannot create a meme or remove a meme. The only entity that can do that is the governance contract. And I will show you later how we do this, how this orchestration of smart contracts become autonomous. And as you can see, that the governance contract has a lot of connections to the meme contract. It calls already, when you deploy the governance contract, it already calls a method on the meme contract to initialize the meme contract and so forth. And that's what we're going to look at now. We're going to take a look at the deployment, because the deployment is one of the more interesting parts of these two smart contracts. We start with these four entities here. Let's say that I'm the initial owner, or I'm the one who wants to deploy this meme governance dApp. So what I'll do first, I will deploy the meme contract. So I'll call the contract management contract. This is a native contract. Most of you probably know this already. You use the contract management to deploy new contracts. So you call that contract. It will deploy the meme contract on a blockchain and then call its deploy method. So now we're all the way on the right side here. Let me see, yeah, here. And the meme contract will set its initial owner. which is at the moment me, because I deployed the meme contract. So far, so good. Now to complete this deployment procedure, we also need to deploy the governance contract. So we're gonna compile the governance contract and call the contract management. That in turn is gonna call the deploy method on the governance contract. And now the governance contract is calling initialize on the meme contract. We deployed the meme contract just before, so we can call it already. And the meme contract is gonna check who initialized this invocation chain. And if it can see that it has been me, the initial owner, it will accept this invocation and it will replace me as the initial owner with the governance contract. So that's where I get out of the game as an initial owner. I get replaced by the governance contract. And at that point, I lose control as a central authority. I don't have the control anymore over these two contracts. So then the meme contract returns and the governance contract can set the meme contract's hash as a property on itself. So it knows what contract it has to call for future invocations. And then the deployment process is over. And me as an initial owner, I have lost all control, basically. I mean, from then on, it's up to the governance, up to the participants to use this contract. And I cannot have any influence over it, any special influence. All right, and with that, we can go over to the code. So what you will see now is contract development using Java. And we're using VS Code, Neo Express as well, and Meow3j, which is the Java library. So we have Meow3j as Gil explained before, the SDK and the developer pack for implementing smart contracts. And I added a link here for you guys. You want to later, if you want to set up a new Meow3j smart contract project, you can use this link. It will give you just some boilerplate code to set up a new project. But now we're going to head over to the actual code. And no, don't worry, I don't always code with these settings like these colors. I just set these colors. I think it's more visible for you guys if I have this high contrast mode going on. So I'm going to keep it. I hope this is okay like this. So let us start on the left side in the file tree. This is a basic file structure that we know from Java. We have our sources here. We have main sources and test sources. In the main, we have our smart contracts classes. And in the tests, we have a couple of tests and other classes we're going to use later. And what's important is that if you work with Meow3j, you're going to use Gradle as the build tool. And here you can see what dependencies we have. We have as a main dependency the dev pack, which is what you will need for smart contract implementation. And then what we use in the tests are other packages of Meow3j, which are part of the SDK. And we have the compiler here that we also use in the tests to compile the contracts programmatically. So in the code, you can call the compiler and you can compile your contracts in code and use them for tests. And below here is an important part. For contract compilation, we have a Gradle plugin that you can use, the Meow3j compiler plugin. And here you set the contract class that you want to compile. And then by invoking Gradle and this task from Gradle, you will be able to compile your contracts. So the tool that we're going to use, as said, is Neo Express for running a blockchain on which we can deploy our contracts. And you guys probably already know Neo Express from previous presentations from DevFog, from Harry. And so I'm just going to spin it up here quickly. I'm not going to go much into it. We're going to start a new blockchain, or let's see that. We're going to reset the blockchain first to make sure that it's clean. Start a new blockchain here, and you can see we have a default .Neo Express file here already, and this is just a one node Neo Express setup. It has two accounts, Alice and Bob, and the consensus node uses Alice's account as its basis. So Alice has control over the Genesis account. So we're going to use Alice later for deployment and invocations. So I'm going to transfer some assets to Alice quickly here. So from the Genesis account to Alice. And that will work. Yeah, right. Okay. So the Neo Express is set up. Then let's jump into the code. We'll start with the meme contract. We can lower this a bit. Okay. So first, just going through the methods we have here. We have a deploy method and the initialization method that we mentioned before. Then we have a couple of read methods here. This you can get the owner of the meme contract. We annotate this with the safe annotation. And this points out that this method will not change anything in storage. It will not do a state change on the blockchain. So I think it's worth to annotate your methods that are read-only with this safe annotation, so that that any client or front end knows which methods it can invoke just for reading data. Then you can create a meme and you can remove a meme. And down here you can get memes by ID or just get all the memes that you want that are stored on the contract. Now I want to talk about the storage structure here. What we have chosen here is we unbundled all the properties of the meme into separate storage maps. So if I show you the meme data object here, you can see that I showed the diagram before. It has these 4 properties, but what we do is we don't serialize those properties into storage, but we have storage segments for each of these properties. So we have a description map, an URL map, and an image map. And the meme ID does not need a separate map. It's used as the keys to these maps. So meme ID is always the key in those maps. Then we also have the contract map, which is something that we usually use for generic information, like meta information on a contract. The contract map in this case will just hold the owner of the contract. So we have an owner key up here, which is a key into this contract map. And here we're going to store whoever owns this contract. Now, you might ask, okay, why do we do this? Why do we do this unbundling here of these properties? Well, yeah, that's a fair question. I mean, you can do this in different ways. There's a multitude of questions that you would have to answer here, I guess. In each use case, you have to think again, what makes sense? Does it make sense to serialize the whole data object, so the whole, in our case, the whole meme object here into storage? Or does it make sense to unbundle it? It depends on, maybe there's only one attribute of your data object that you need to change often. Then it would make sense to take out that attribute out of the object and create a separate map for it and just serialize all the other attributes. Let me just show you in here how you could do it. You could set up the meme as the meme object, as the data object in this class, and then use the standard lib.serialize method to serialize this object into a byte string, and then use a single map to store this byte string. And then when you want to read it again, you just do one get from the same map, and then you use standard lib to deserialize again. So you can see that's obviously less gets, like less reads and writes to storage, and storage reads and writes are quite expensive. So it makes sense to avoid them as much as possible. But you also need to, if I go back, you need to take into account that serializing and deserializing obviously also costs gas, and the amount that you store also costs gas. So if you store just one small property like a meme ID in a storage, or if you store a whole serialized object in a storage, you will pay more for the serialized object. But again, you will have to, in the end, if you really want to know which implementation is better, you will probably have to do experiments with 2 separate implementations. Okay, so then let's move on here. In this contract, I just want to go more into detail on these 2 methods here, the create meme and remove meme. I said before that only the owner of this contract, which will be the governance contract, only the governance contract will be able to change the state of the meme contract. And this is done in this line here, where we check if the calling script hash is the owner of this contract. And we'll see again, the deployment procedure will set it such that the owner is the governance contract. And then this, this expression here will only evaluate true if the calling script hash is the governance contract. And so if anybody else calls here, this method is going to fail and return false. So only the governance contract can change the meme contract state. Right, then having said this about the governance, we're going to move on to the governance contract here. The governance contract is, as shown, has a couple of read methods here as well, annotated with save. Just for getting for fetching basic parameters like the voting time, for the minimum number of votes that you need to have an accepted meme. Then we have the most important methods: propose new meme. We have propose a removal of a meme, which is the opposite proposal, of course. And then we have the voting method, and down here the execute method, which is needed to, after the meme's proposal period is over, after the voting period is over, you can call the execute method to actually execute the proposal. And let's go up all the way. And here I want to show you the permission, this line here. I think it's important to mention this, that setting permissions on a contract can be valuable. You can tell the users of your contract, or you can gain more trust, or they can gain more trust in your contract, because they can see what contracts your contract is allowed to call. If you have, as it is now in this setting, my contract can call anything. I can call the gas token contract and try to do a gas token withdraw from your account, for example. So it makes sense to set this more specifically. So I'm gonna go over here. I have already the script hash of the meme contract. So I'm gonna set this to the meme contract. And now we know that the governance contract is only allowed to call the meme contract. So this information will be visible in the contract manifest, and it will be enforced by the Neo node. So the users can see it, and the Neo node will restrict your contract from calling any other contract. So I think it's important to have these things set. It will give your users more trust. Again, going into the storage topic here, you can see we unbundled everything. We don't have one storage where we have the whole proposal saved at one time. And now in this case, we can see, okay, now it's probably going to get more expensive the way we do it here, because if you do here, if you propose a new meme, you will see that you get all these maps, and you have to put all the data of the proposal and of the meme that is being proposed into these maps, and you have a lot of put calls, which are quite expensive. So this is just for showing that at some point it makes sense to switch to serializing the whole object, especially here where we don't change single properties of an object, but we always store the whole object, delete the whole object, and retrieve the whole object at once, and don't change single properties of it. Okay, so much for the storage. And now quickly I want to show you the deployment process in code. We're going to start with the meme contract. We're in the meme contract here. You can see that the deployment method expects a data object here. This data object has to be a hash 160. So this is going to be the the address or the hash of the initial owner. That's what we do here. We set the owner key to whoever is calling this deploy method, who is deploying this meme contract. So if I deploy it, I'm going to pass my own script hash of my account to this method. And so then after this deployment, I'm the initial owner. And then we continue with the deployment of the governance contract. This is happening here. This method is going to be called. And this method also expects a hash 160, a script hash, but it expects the script hash of the meme contract. So that's what we do here. We get this data input object and we expect that it is the meme contract hash. And what we do with this is we immediately call the meme contract in this line. We call the initialize method. And if we go back to the meme contract, you can see this goes into here. And what is happening here is it's going to check witness on the owner. And at this point, the owner is still me, right? I deployed the meme contract. So the transaction that led to this invocation here has to be signed by me, and that's what I did when I deploy the governance contract. I sign it with my private key, and then this check witness here will be successful. And what is then happening is that the owner key is going to be replaced, or the owner hash is going to be replaced by the calling script hash, and that is the governance contract at this point in time. So then that's where I'm out of the game, where my hash is overridden by the governance contract's hash. And if everything is successful, then the governance contract will set a reference to the meme contract here. Okay, that's the deployment. I can also show you the create proposal and vote and execute. We've seen it before. It's pretty simple. If the meme that's being proposed already exists, or if the proposal already exists, then we're going to fail. Otherwise, we're just going to insert the proposal into storage of the governance contract. And we're getting the timer here, basically, where we want to know how long is the voting period of this proposal, and it starts at the current index and ends in 10 blocks. We have set this to 10 blocks, just the voting time. And then I'm going to skip the removal here and go to the vote. This is the voting method. When you call this, you pass yourself as the voter, and you have to provide your signature. So you have to prove that you are this voter. So you cannot vote for anybody else. You can only vote for yourself. Then down here, we get a map in storage that is specific to that proposal that is incoming here, that is being voted on. And we check if the voter that is voting has already voted on this proposal. So you can only vote once per proposal. Obviously, we want to make sure that you can't just have an army of bots that is going to vote in with the same account all the time. And then afterwards, we're just going to increase the vote count, like the overall vote count, and the vote count specifically if it's for the proposal or against the proposal. And then after the voting period is over, somebody has to hit the execute method, and that has to be done manually. Like, we can't set a timer on the blockchain. That is a known there's a known problem on the blockchain, that we cannot have a timer inside of a smart contract. So we can't tell our contract, okay, please execute yourself in 10 blocks. So the execute has to be called by an external entity, usually probably the one who created the proposal. And in here, we're just going to check if the proposal has been accepted, if there are enough votes in favor for this proposal, and if it's a creation proposal, then we're just gonna get the meme data and call the meme contract in this line here. We call the meme contract and pass it all the meme data, and then the other options are for removal proposal or for proposal that has been rejected and so forth. Okay, and we're running on low on time here, but I'm just gonna show you quickly one more thing. So I've prepared some scripts here, which you can use for deploying. Now this is also Neo3j, also Java, obviously, but this is the SDK part of Neo3j. What we've been using so far was the dev pack. This is smart contract. The smart contract part of Neo3j, and what we're going to use now is the contract module, which is the part of the SDK of Neo3j, which is used to build around blockchain. So we set up a connection to our node. This is a connection to NeoExpress. NeoExpress is running at this port 4332, and we have these files here that are that we are going to compile the contracts, and they're going to be in those locations. I'm going to show you that just in a moment. We set up a connection to the contract management contract here, so we can call its deploy method, and then we have an account and a wallet where we have control over Alice's private key. So what I want to do first is compile the contract. Just change here. So as you have seen before in the beginning, I said that we have the Neo3j compiler plugin, and we set here which contract we want to compile. And so now we can compile like this. And this is going to use that meme contract and compile it. So you can see here where it has put the binaries. And we can do the same for the governance contract. Compile again. And you will see now we have the governance contract also compiled, and we know their location. They're at build Neo3j, and that is where these file paths up here are pointing to. And now we're going to use these files and deploy these contracts. And so we load the NEF file, we load the contract manifest, and here we call the contract management, and we call its deploy method. So this is a convenience method here, because it's a native contract. We know what methods it has. So we have these methods here right in Java, and we can pass it the NEF and the manifest, and we also pass it a contract parameter. And this is why I'm not using NeoExpress here, because NeoExpress would, usually I would do this, deploy contract to NeoExpress. And here I can choose Alice, and then I can choose my contracts that I want to deploy. But then I can't pass the parameter. So that's why I'm using Neo3j right here to pass parameters. And this is what I do here. I pass the owner hash, which is Alice itself, right? I want to be, okay, I'm Alice. I want to be the initial owner, so I pass my own account hash. Then I sign the transaction. What we're doing here basically is building a transaction in a builder fashion, right? We set the signers, we set where the signer's private key is. It's in this wallet here. And then we sign and we send the transaction. And then if there's no error, it's fine. We can go on and we can get the transaction hash of the transaction that we just sent. And then wait until it's included in a block. This utility is doing that for us. And then we can print out the contract hash. So the contract hash of our is dependent on the sender. So we have the Alice script hash included here, and the checksum of the NEF and the manifest, the name that's specified in the manifest of the contract. And then we deploy it. So I can run this here quickly. And then depending on, it could take up to 15 seconds until we see the result. Since it can take 15 seconds to use a block. And yeah, now you can see meme contract has been deployed. This is the same hash I already had here. What we can check on now is who the owner is of the meme contract. And that should be me or Alice in that case. We could do that here. We can set up a link to the meme contract here with this smart contract class. And then we can call a function on this contract, and we call the get owner, and we will see that the owner is myself. With this address here, if we go to Neo Express, we can see, okay, Alice, yes, NM7A. That's me. And then if I now move on, I'm doing the same with the governance contract. I'm going to deploy the governance contract here. And afterwards, we will see that, that the hash has been replaced by the governance contract. Okay, the governance contract has been deployed, and I'm going to get the owner again of the meme contract. And we can see now it's a different one. It's actually the governance contract. This is the hash. Yes, exactly. This is this hash of the governance contract. So the deployment was successful. I've been removed as the initial owner, and now people can start voting. One last thing I want to point out, and I have to stop, is the witness scopes. Let me show this first. Up here, this signer. Okay, Alice is the signer, but we only have a fee-only witness scope. So the only thing that this signer needs to verify, or the witness of this signer, is used only to pay the fees of this transaction. Nothing else is needed. But now here, when we deploy the governance contract, we need a more sophisticated signer. And this signer allows this contract here, the meme contract, to use the witness. So only this contract specified here is allowed to use the witness that I put on the transaction. And this is obvious because I need it in here, right? If I deploy the governance contract, let me jump a bit around. I go to the governance contract, in the deploy method, I call the meme contract initialize method back to the meme contract, and I get here and I do a check witness. And here I need the witness from the transaction. So that's why the meme contract gets the permission to use this transaction's witness. And yeah, that's it. I have to stop here now. And I think we're going to go right over to the question and answering session now. So Ping, can I give you the
yes.
the lead?
Yeah. Yeah. The Songping, please.
Yeah, I think like the team actually have already answered a lot of questions during the presentation. So we still have time, I think probably for 1 or 2 questions, if there's any. So as usual, any participant, if you have further questions, please use the raise hand function and I will unmute you. Okay. It seems that all questions are answered already.
Yes.
Okay.
But
Okay.
yeah, I think it's great to expose like all this knowledge that you know to the community. And just to reiterate here what Claude said before, that we are willing to help and support people willing to build something using like the examples that we provided, using the L3J, using the dapps, the boilerplate that we provided. So yeah, I think it's awesome times, and let's keep the motivation, guys. Yeah, thanks a lot for your time.
Thank you, Gil and Cloud, for the great presentation today. And thank you everyone for spending the time and really dig into the development on Neo N3. So one more thing, we actually arranged an office hour. So same time slot, but tomorrow. So anyone have further questions? It's not like a certain topic specific. So any like development, I mean like N3 related questions, you can come to the same time. And also we're gonna share the Zoom link later. So just come and we will have most of the team online to answer the questions.
Yes,
Perfect.
absolutely.
Yeah, one of Axe Labs is going to be there as well.
Yeah. Okay, so I think that's all for today. Thank you everyone and see you soon.
Cheers, take care guys. Bye-bye.
Yeah, thank you. Bye-bye.